Thank you very much. Hi, my name is Tayo, and I'm as a introduced TikTok Privacy Innovation Lab. Today, I'll talk about secure and private platform for secure data collaboration that we're building at TikTok, which is one of the major use cases. So here's the overview of the talk. I'll talk about the data collaboration and why existing solution didn't meet our requirements. I'll talk about our approach and use case demo. And finally, I'll talk about our plan for the future. So I'll start with what data collaboration framework. I believe that it's pretty common concept, but I want to define it. So data collaboration framework allows multiple parties to collaborate on data. For example, a data provider may make their data available to their consumers, and so that the consumer can perform some various analysis. In such framework, the data platform allows data provider to control not only the security policies, but also like privacy policies. So it's not only about the permission control, but also when they want to control some privacy policies like data retention or purpose limitation, the framework needs to provide those. And then also finally the platform needs to provide the consumer with the tools to utilize the data, such as interactive data query interface. As a generalization of this data collaboration framework, multiple data providers and consumer can get involved in this collaboration. For example, there might be more than one data provider, or each of the data provider can be also a data consumer, for example. In such multi-way setting, the platform needs to provide users with tools to securely collaborate. So there are two issues, as we all know. One is the security. How can we share the data securely? No matter what data you're going to share, the confidentiality, integrity of the data needs to be protected. But it's not the only requirement when we deal with the very privacy-sensitive data. So for private data, we also need to think about how we enforce privacy policies. For example, purpose limitation requires the data to be consumed, collected, and processed only for a specific purpose with explicit consent from the individual. Or the data retention policy requires that the data persists only for a defined period of time. So here's the thing. So we had several requirements for the data collaboration platform. So first one is the usability. So the platform needs to provide an interactive tool to utilize the data, such as data querying interface. Security and privacy, of course, we want to have it. So for security, we need to have a strong access control. Privacy, the platform needs to make it possible to enforce privacy policies. The accuracy, for any data analytics we provide, we don't want to compromise the accuracy of the results. Finally, it should be really easy to deploy. Those are our goals. So let me talk about some existing solutions and why we choose our approach. So there are a lot of existing solutions. It's not a new concept. First one is the SQL policy-based data clean rooms. It's very common in the industry where a data platform provider, the data platform is provided by a third party who does not have any conflict of interest. And in those platforms, usually they rely on some query policies, like fine-grained policies, such as who can run which query on which table. So differential privacy is another way of achieving private data collaboration. So it's based on mathematical foundation to limit the information leakage of certain data set or queries. There have been a lot of proposals for using trusted execution environment. The idea is to use its remote attestation to co-verify the code when different parties collaborate on the data. Before releasing the data, they can perform the remote attestation. And this will be securely protected in the remote platform by the isolated environment provided by the TEs, right? However, we found that none of these solutions meet all of our requirements of data collaboration. So while policy-based data clean room provides great usability as well as accurate result, we find that it's a little bit tricky to kind of enforce the privacy protection as well as the privacy policy enforcement. I'm not saying that it's impossible to do that. It's a little bit tricky to enforce privacy policy. For example, if you think about the purpose limitation, when you allow them to query on some table, it's very hard to control like what they do with the data. Differential privacy provides great usability. However, it needs to sacrifice some accuracy because you're basically adding noise to either the data or the aggregate result. So the proposed trusted execution environment solutions, on the other hand, seems to be a good solution. But one problem that we found was that its attestation mechanism is not really useful for interactive interface such as dynamic data querying interface. To this end, we designed a two-stage data clean room that combines different technologies to balance usability, accuracy, and privacy. So the main idea is that coming from the data collaboration can be divided into two stages with different requirements. So in the programming stage, the programmer only needs small data and compute resources, and they want to use some interactive programming interface like Jupyter Notebook and want to use some different languages like Python. And at this stage, the data is hard to control. So it poses higher privacy risk. On the other hand, on the execution stage, the programmer may submit their complete job to the isolated environment. Because it's going to run on actual data, it will need like a large data and compute resources, and it only run for one-time execution. But since it's like run to completion model, it's really compared to the programming stage, it's easier to control the data and thus has a lower privacy risk. Based on this observation, we have designed two-stage data clean room solution. So in the programming stage, the platform allows the data consumer to explore the data set by providing using the interactive tools. And to protect the data privacy, the data provider can provision two different data sets depending on their security or privacy requirements. So in the execution stage, the complete workload runs in an isolated and attestable environment based on TEE, such that the data providers can manage the data code and outputs based on the result of the attestation. So let me talk about what's the benefit of two-stage data clean room, especially what TEE provides in this scenario. So first, a data provider can decide a protection mechanism for when they're provisioning their data. For example, in the programming stage, they can choose to provide only the random data, which shares the same schema, or differentially private synthetic data, which was generated maintaining the statistical characteristic of the original data, or just the public data that doesn't have any privacy risk. In the execution stage, you can actually implement a coarse-grained policy based on the code or the output of the code execution instead of per query policy. The benefit of using trusted execution environment is for the multi-way collaboration. It kind of provides transition of trust, which means that when there's multiple party who has a conflict of interest, you can still not need to trust one of the party in the collaborating session. Secondly, it provides integrated code and output for the security. It protects the in-use data, so it provides a security-wise benefit. And then finally, one interesting thing is that the attestation report of this workload can be used as a proof of execution. So it means that given an output, you can prove that, okay, this output was generated by the workload here that has the hash, the measurement of this, for example. And the other benefit of employing TEE instead of differential privacy in the second stage, execution stage, you can fully make the full data accessible to the workload without having to, sacrifice the accuracy of the result. So we have built this system on top of cloud. So we hope to have it as a multi-cloud backend. But basically, it consists of the front end based on the Jupyter Hub, which talks to the data clean room API, and then that talks to the cloud resources to manage these T instances. So ideally, the cloud part can be replaced by on-prem T infrastructure or different cloud providers' resources. So let me talk a little bit about use case. So providing transparency is very important responsibility of large social media companies like TikTok, as its data can be very, very valuable to public domains such as public health, economic impact, studies. So at TikTok, we're committed to provide as much transparency as possible to the community, but also it's very important to respect the user privacy when we do that. We have built a solution called Virtual Compute Environment, which provides maximum transparency to the researchers with minimal privacy risks. So TikTok's VCE leverages our solution, our two-stage data clean room solution approach to balance privacy and transparency. So you can check out the details from this link. We're exploring another potential use case of this data clean room solution. Obviously, ads and marketing, it's a very popular use case for the data clean room for doing the analysis on lookalike segment for the lookalike segment audiences, or ad tracking like measurements and conversion tracking. Another interesting, again, obvious interesting use case would be machine learning, where this data provisioning different in two stages can be beneficial to like private data set, either private data set or private models. So let me show you a demo of our platform. So the scenario is like this. So we got insurance charge data set from Kaggle. So our goal is to train a model using XGBoost regression, train a model that predicts an insurance charge based on their private information. So for the programming stage, what we did was we generated the differentially private synthetic data based on MSD algorithm. This is the winner of 2018 NIST Synthetic Data Challenge. So here's the demo. So we provide Jupyter notebook interface, and what you can do is that in order to explore the data, you first install all the dependencies and then import all the dependencies, right? And you basically using our SDK to connect to backend data storage. Now you can explore the data, but since this data is generated synthetic data, you don't leak any privacy. And you can explore basically the distribution. You can see pretty much similar, statistical distribution of the data, or you can even see the correlation between different columns. So you can see that, yeah. Sorry, what's happening? Yeah, sorry about that. Yeah, so it talks about the age, sex, BMI, how many children each of the individual have, and so on. And then once you're done with exploring the data set, you can submit it to the data clean room, and it will build the image in the backend using the cloud-provided TE. And if you wait a while, once the image is built, it will run in the Google Cloud. So you can see that it's running on the confidential space as a backend. And then once the job is finished, you can actually download the output and check it check the result here. So now you can see the results of the actual output. So you can see that, okay, there's smoker or age and BMI, those are the main contributing factors to the insurance charge. Now we're going to build the regression model. So do the same thing. We install the dependencies and import libraries and pre-process the data again. And then we basically train the model based on XGBoost. So we split the data set, make a regressor, and then train it. So you can see that you can do that, and then once you're done with programming, you submit it to the secure execution stage. So same process to build the image, VM is running, and then once it's done, you can check the output again to see how accurate the model you trained is, right? So one other good thing about it is that, as I said, you can download the attestation report. So this attestation report is basically JAWA token generated by the confidential space. So you can publicly verify this based on the key ID that is provided by this report. And it's posted by Google, so you can copy and paste the same key and then verify the signature to validate this report is valid, signed by the Google confidential space. And then you can check all the attributes in the attestation report. So it's run in confidential space. You can check the image digest, which you can basically reproduce by yourself using the Canonical image builder. And then you can also see the execution, what the image executed. Finally, you can also check that the output hash matches the nonce of this report, which means that this output was genuinely generated by this program run on the TE. Right, so that's a demo, and let me cover some of the lessons we learned. So confidential computing is a valuable tool, not only for security, but also for privacy, if you use it correctly. And then confidentiality is only one aspect of confidential computing. So if you look at our use case, we really benefit from all different kind of good properties like integrity protection, attestation, and also transition of trust. And also we realized that cloud-provided confidential virtual machines can accelerate building T-based application. There are some caveats, but it really has a lot of tools readily available, so it was very accelerating the building T-based application. So right now, we only support one-way collaboration, but in the future, we would like to extend to a multi-way collaboration where each of the users can bring their own data and collaborate. So currently, we only support single backend, which is Google Cloud, but technically, you can add more backend like Azure or on-prem TEs if you want. So currently, data provisioning and policy attestation, those are like manually done, but in the future, we're planning to automate this part. And also, once it's available in the cloud, we'll be able to add a GPU support for these. So actually, we're open source this project for transparency and visibility. So you can check out the GitHub, our GitHub, TikTok privacy innovation / privacy go - data clean room. So this is our very first version of data clean room. You can see and actually try it if you have a Google Cloud account, and you can build something on top of it. Yeah, thank you very much. That's all. I'm ready to take any questions.
I think we have time for one question. Anybody?
Great presentation. I had a quick question just about a lot of the protections here seemed very focused on input privacy and compute protection. Could you speak to any consideration on output privacy, just in terms of what might be inferred or deduced from functions?
So what we're thinking is the outputs are, it's because it's coarse grain. You don't have to like set a policy like fine grain policy. So what we're envisioning is that we may be able to automate some part of the filtering. So what the system needs to do is that when the output tries to, let's say, dump all the individual columns, we can mask those things. And I think there are tools to prevent those kind of things. So I think output filtering is easier than setting a fine-grained policy on data query. So yeah, I think that's a very good question, and we are hoping to add some automated check for that. But right now, the assumption is that you can basically manually screen that. The data provider, each of the individual data provider can manually check that. And in multi-way setting, you need something automated, and we don't have that yet.
All right. Thank you for the excellent talk. Appreciate it.
Thank you very much.